Big news from the universe. Today, astronomers announced that they found the first evidence for a stochastic gravitational wave background. Stochastic means random. Gravitational waves are the ripples in space that are produced when violent gravitational events happen in the universe, like the collisions of black holes. And it's a background because we see evidence for those gravitational waves existing throughout the cosmos, but we don't see like a single source of them. Now, you've probably heard about gravitational waves before because we have detected gravitational waves from black holes colliding in other galaxies, black holes with masses consistent with the remnants of stars, so 10 to sort of 50 solar masses. Now, this background is consistent with the collisions of supermassive black holes in the centers of galaxies across the universe. So we're talking black holes that are like millions or billions of times as massive as the sun. Black holes collide in the centers of galaxies when galaxies collide, like in this little image here. So we've known for a long time that there should be a background of gravitational waves passing through the universe all the time from black holes in the centers of galaxies colliding across the universe. But this is the first sort of evidence for detection of that gravitational wave background. It's kind of like the ripples in the cosmic sea, and we're just starting to see those ripples. Now, the way the detection was done is really cool. Astronomers observed pulsars, which are these dead stars that have jets of radiation coming out of them, and they're spinning around really fast. So when they spin around, the jets pass across the Earth and we receive a pulse. That's why they're called pulsars. These stars pulse at like millisecond periods. They're spinning very, very quickly. But they're very, very regular, so we can time them really well. What these astronomers did was they measured the timing of all of these pulsars across the galaxy for 15 years, and they looked for little deviations in the timing. Those deviations can come when gravitational waves pass between us and the pulsar. So if you have a whole bunch of pulsars and you have a bunch of little deviations in the timing, you can find correlations that will tell you that those deviations are from gravitational waves passing through the universe. So this detection was from the NanoGrav collaboration. It's technically just evidence, not really a detection. We should be careful about that. But other pulsar timing arrays are looking for data too, and we're going to learn so much about supermassive black holes and the history of our cosmos. So stay tuned for that.